For micro-dispensing, there is one product line that is proven and trusted by manufacturers in semiconductor packaging, electronics assembly, medical device, and electromechanical assembly the world over. DL Technology, superior pumps and needles for the finer things in life.
Welcome to the MODUS stand here at Productronica. Delighted to be joined by the Geschäftsführer, of course, Gerald Land. Nice to see you, Gerald.
Yeah, thank you for coming, Trevor. It was a pleasure to me to invite you over here.
Thank you. So we've got something new and exciting behind us, which is your first 3D system, which you're really developing for the box build side of the factory.
Yeah, that's correct. We call it Sense 3D. This application is a pre-production mode, and we are going for the back-end application, especially for box build, and even for inspection during the second stage after the SMT process.
Right. Okay. And it's going to have full. The final model will have full metrology. You'll be able to measure. Final assemblies to make sure they're accurate, etc.
Yeah, of course. At the moment we have just the pre-production stage, but this is the plan that we have finished this, and we will launch it by end of next year as a full product, and it will be a product line. This is the first stage, and even we will integrate in our scan units as well, that we have a real 3D application, even in line processing.
Yeah. Well, I mean, 3D is something that it's been around for a long time, but some of the issues with it has been trying to get the placement correct on a 3D assembly, etc. But you can also. But if you have something that can do inspection as well, that's going to be quite important.
Yeah, that's true. Yeah. Yes, the inspection is a classical inspection, what we can do. Even the test modes will be the same, because we have a lot of experience in terms of the normal standard inspection for 2D. Even we will increase some specialties, even that we have a cut-through. And you see the dimensions, measure the dimensions, and even we have some other ideas to turn around the system, or we can see the component itself, or we can see any other components on it that we can measure and make the metrology application more capable.
All right. So, anyway, the exciting thing about that is, of course, the box build area is the most labour-intensive area in the factory space. Now, we're not looking to necessarily replace labour, but it brings that you can improve quality, because anything that you can automate improves the quality.
Yeah, of course. That is even all the trace data will be collected, and even the quality issues which happen. Nobody knows really, because it's human-based judgments, and now they need digital data for that. So this is a big part in the future, which will happen.
Okay, so your colleague here, Felix, is going to give me a demonstration and talk to me further about it. So thank you very much for coming in, Gerald, and we'll see you again. Thank you. So Felix, nice to see you. Give us a run through on how the system works.
So the system is basically a light field scanner, if you like to formulate it. It consists of multiple cameras in a single module. So these are 25 megapixel sensors in a linear array. And the modules can be cascaded, so you can have multiple modules in one system. So in this case here, we just have one module mounted on a robot. We also have an application where we have multiple of these modules mounted in a scanner, so you can capture a larger field of view. Of course, with the robot, it's very flexible. You can look from different angles on different parts. You can move exactly where you need to be with this system, and you can capture 3D data. That's the very important thing here, because we have multiple cameras. We can compute depth information for the overlapping areas.
Right.
Yeah.
So you're capturing the data using step and repeat. Is that correct?
Yes. If you choose to do so, of course, it's always a trade-off between the scanning time and the accuracy your model will have later, and the field of view you can capture. Right. So in this case, we just do a single snapshot from the top and capture depth data from that. This is already enough, and it's quite quick. We also plan to improve the quickness by a lot by implementing an FPGA-based approach. Right now it's just CPU and GPU-based for high performance.
Right. Well, of course, you're going to be collecting a lot of data. So what about processing all that data to get into, make it into some meaningful, actionable data?
Yeah, of course, there's a lot of image processing going on behind the scenes here. Capturing 25 megapixel images and then capturing multiple 25 megapixel images is a lot of data. So for one large scan with the scanner application, we have about 90 images, and this gives you about 20 gigabytes of data that have to be processed. Yeah.
Okay. So can we see it going through some dry runs? Okay. So the version we're looking at the moment in the background here is it scanning a PCB in this stage, but PCB is obviously offset at 45 degrees or something, so it's at an awkward angle, if you like.
Yeah, this is just for show, just so you can see the PCB a bit better. Yeah. As I said, you are very flexible with the robot to look from whichever angle you choose.
So the other application you have is also to be able to look at the conformal coating. So maybe we can have a look at that. That's in the sample right behind me here. Okay. And tell us about this.
Yeah, so here for this demo we just chose to mount additional UV LED strips to the camera sensor, so we can inspect conformal coating using the UV LEDs and fluorescence coating.
Okay. Excellent. So it's got multiple uses, multiple angles, and I'm sure we are looking forward to the production model coming out at the end of next year.
Yeah, we are of course too.
Okay. Thank you very much, Felix.
Yeah.